Right, so today we will be discussing friction.
This is static and kinetic. Static and kinetic.
Yes, static and kinetic friction. So this friction is actually an opposing force. Okay, it opposes. When we stand, then also friction force acts. And when we move, so some force is there which is opposing our motion. So it happens for each and every body which is having mass. Okay, body which are having mass will be subjected to a frictional force. Okay, so what we can say that any body what means okay, any body which is having mass will be subjected to a frictional force. Subjected to a frictional force. Right. Correct? And this frictional force, actually it is opposition force. This frictional force is opposition. Opposition force means it opposes the motion. Okay, so as if the body is static, then it will be static friction. Once the body has started moving, then it will be kinetic friction. Okay, so that's why friction has been divided into two categories. That is, first one is static friction. Means when the body is at rest. When the body is at rest. Similarly, another one, kinetic friction. So kinetic friction when the body is in motion. See, any body is there when it is kept on a surface. Suppose this is a leveled ground parallel to the ground. This object is kept here, having mass. Some mass m is there, whether 2 kg, 3 kg, it doesn't matter. Whatever mass is there, when it is kept on this level ground. So due to its mass, its mg, that weight will be acting downwards. Weight will be acting downwards, that is mg. And weight is a force? Yes or no? Weight is a force. Similarly, this friction also it is a force. A force which opposes the motion, that is called frictional force. Okay, so this is also a force. It is not different. Frictional also it is a force. So when this mass of the body it is acting, means the weight of the body it is acting downward. So what it does? It is making this body steady. It is not allowing it to move. So in this position, when it is in a static position, there is a force, frictional force, which is acting. Where it is acting? It is acting on the surface of contact. This frictional force is not acting at the top of the body. It is not acting at the side of the body. It is acting where? On the surface of contact. Okay, so on the surface of contact. So in this surface it will be acting. If suppose you apply a force, if you are applying a force on this body to move it, right? So when we apply a force to move this body, this particular body, what happens? This force will try to move this body. Now, a frictional force will exist. It will also start acting in opposite direction. So this frictional force F, it will start acting in opposite direction. Till the time the body is not moving, okay, we will call it as Fs, means static friction. The moment the body will start moving, from that position, it will be kinetic friction. Before that it will be static friction. And static friction is having its own limit. Okay, so until unless this force is not overcoming this frictional force, means when it is not more than this frictional force, body will not move. Okay, so that we are finding out. Okay, with the various formulas and all. So in this case, suppose you can say this is F. Weight is acting downward in this one, and simultaneously an opposition force. You know that Newton's third law of motion. So Newton's third law of motion says that whenever a force acts as an action, there will be a reactive force in equal and opposite direction. So equal to this, a normal reaction, and normal reaction always it will be perpendicular to the surface of the body. Perpendicular to the surface of the body. Okay, always it is acting upward, perpendicular to the surface of the body. Yes or no? So in this particular case, you can say that normal reaction N is what? Normal reaction. See, normal means perpendicular. Normal itself means perpendicular. So normal reaction is equal to mg, as the body is static. So this normal reaction is equal to weight of the body, mg. Okay. Now if in this case this F, and what this friction force, static friction force, is equal to mu s n. Why? Because this static frictional force is proportional to the normal reaction. This mu s is the proportionality constant, which is called coefficient of static friction. Okay, so this mu s is coefficient of static friction. Till the time the body is static, coefficient of static friction will be there. When the body will move, at that time this mu s will get replaced with mu k, and this static frictional force also will be getting replaced with Fk, and it will become mu k n, and mu k is coefficient of kinetic friction. Coefficient of kinetic friction. Coefficient of kinetic friction. Correct? Okay. So this is the mu coefficient of kinetic friction, and then mu s is more than mu k. One more thing you just note it down, that mu s is more than mu k. Why? Because you need to apply a little bit more force to make the body move. The moment body has moved, after that it will become easy to move it. Correct or not? Okay. So this mu k, coefficient of kinetic friction, is always lesser than mu s. If it is always lesser, so you can say that the static frictional force, because mu s will be greater than mu k, it means the static frictional force will be greater than this kinetic frictional force. Correct or not? Because mu s is greater than mu k, and both place n is same. Once it is same, it means mu s will be greater than mu k. Okay, so you can say that Fs is greater than Fk. Static frictional force will always be greater than kinetic frictional force. Okay, right. So this was there for static friction. Just note it down.